In this section, we will introduce two important analyses for project evaluation. The first analysis we're going to learn is the scenario analysis. This example in the Excel is also the example from our slides and textbook, where this project with initial cost 200,000. The expected project life is 5 years, required return is 12%, tax rate in 21%. We also know the sales price, variable cost, fixed cost. First step, we need to estimate the base case situation. Similar as what we did in the last chapter, the projected cash flow, and then we will calculate the NPV and IRR for the base case. After we got the results for the base case, we can rely on the scenario managers in Excel to estimate for the best case and worst case scenario. Let's first estimate the base case income statement. Okay. The sales for the base case, we used the unit sales times the price. Let me show the formula here. The variable cost is equal to the unit sale times the variable cost per unit. Fixed cost per year is 50,000. Depreciation, in the question, depreciation is straight line to zero. It's a straight line. We will use the LN function. The initial cost is 2,000, no salvage value, and life is 5 years. The EBIT should be the sales minus the sum of all the costs is 30,000 per year. It's 30,000 per year. The taxes we need to pay is the EBIT times the tax rate. Net income will be EBIT minus tax payment will be 23,700. This is the pro forma income statement for the base case. In last chapter, we learned the way to calculate the operating cash flow for this project. If we use the bottom-up approach, will be the net income plus the depreciation. Use the operational cash flow, we can estimate the NPV and IRR. Since the operating cash flow is for every year and we know the initial cost, right? We can treat the operating cash flow as payment every year. And we can calculate the NPV, use the PV function here, Required return is 12%. We have 5 years. Payment every year is the operating cash flow, right? And we also need to include the initial cost, 2,000. This is for this base case scenario. We used the PV function instead of the NPV function. Similarly, we can use the rate function to calculate the internal rate of return instead of use the IRR function. If we apply the rate function, we know the number of period 5. The payment for each year is the operating cash flows. The present value is the initial cost. We don't have future value. 17.82% is the IRR for this base case scenario. Notice here we use the alternative way to calculate NPV and IRR. If you have the same cash flow every year, we can use the PV function and rate function for the NPV and IRR. Before we get into what-if analysis, the scenario manager, and sensitivity analysis, make sure you use the cell references correctly because later our analysis will based on the base case calculation here and make sure you use the correct cell references and everything linked to the input section here. Next, we will conduct the scenario analysis. We will go to the data what-if analysis scenario manager. Let's first start with the base scenario. Next, we will enter the changing cell, the variable we like to see in the scenario analysis. The variable we are going to change include the sales, not with the calculation. Well, the unit sales, price, variable cost, and fixed costs. You can also select the 4 sales and you click OK. The Excel will ask you to enter value for each of the changing cells because this is the base case. We don't need to change anything. We just click. There we establish the base scenario. Next, we'll continue add the best scenario. The best, we click and we need to change the values for the best scenario. Here we have the best case. We have 6,500 unit sales and our price will be higher, 85, the lower variable cost and lower fixed cost, 45,000. Click OK. We have best case established here. We continue for worst case. For worst case, we have lower sales. We have lower price, 75, and we have higher variable cost, 62. Fixed cost also higher, 55,000. Here we established all the three scenarios, best, worst. We have some button here. Be careful. Do not click show. When you click show, the Excel will show you the numbers in your scenario. If you happen to click best or worst, it will show you the number with the scenarios. If you accidentally click it, you can always click base and click show. It will show you the base case numbers. What we will do next, we will click summary. For summary, we will generate a scenario summary for our analysis. That's the results we want to see in the Excel. What we need to enter is the result. So in our analysis, the result will be the NPV and IR for each scenario, right? We click, the Excel will generate us a scenario summary for each scenario. The current value, base scenario, best and worst. The current values is the numbers in our current worksheet. And it should be the same as the base case because we calculate based on the base scenario. Then the best and worst is the calculation from the scenario manager. If we have different sales and price, NPV and IR will be different from the base scenario. This is the results we want to see in the analysis. With the scenario manager, it's very efficient. If we have more scenarios, you can create as many scenarios as you want and change different values each time, and we can see different NPVs and IR in the scenario summary. Next, we'll introduce another important analysis. It's called sensitivity analysis. The difference between the scenario analysis and sensitivity analysis is that for the scenario analysis, we can change several variables at the same time for each scenario. But for the sensitivity analysis, every time we only focus on one variable for the sensitivity analysis. Let's look at the example here. The function we have used many times in previous chapters, the data table function. Everyone should be familiar with this function already. Let's look at how to apply it in the sensitivity analysis. To apply the data table, remember we first link to the original function of the NPV. In this example, we will perform sensitivity analysis using the fixed costs. We will look at how the NPV changing along different fixed costs here. Using the data table, we will select the two columns here. Then we will go to what if analysis data table. Because it's only in the column, we'll enter the column input cell. We link to the input section fixed costs per year. It's D12. We click, the Excel will generate NPVs for different fixed costs. And graphically, the relation between the fixed costs and NPV will look like this. It's a downward line. Higher the fixed costs, lower the NPV, which makes sense, right? We can see different NPVs for different fixed costs. There is a negative relation between fixed costs and NPV. Here is a more advanced example for the sensitivity analysis. Many times we have two variables change at the same time. For example, if we have higher price, probably we expect lower unit sales, right? We can do two-way data table in this example. First, we still link to the original formula of NPV. This is the cell references for NPV. And we select the table go to what if analysis data table. Right now we have two input cell. Okay. In the row input cell is the price. Here's the price. D10. Right? For the column input cell is the unit sales, D9. We click OK. The data table will generate two-way sensitivity analysis. We can see here the light pink area is the situation or the condition that we may have the positive NPV. Any numbers in the dark pink area is the negative NPV, right? Here, most likely, if the price is below $8, we more likely to have a negative NPV. Here is the clearer cut for this project may have the positive NPV or the negative NPV. In the end, we will have a sensitivity of NPV to changes in different major input of this project. We will generate a graph show clearly how the NPV changed to the different input variables. Let's look at this analysis. We need to first complete the changes for each variable, how each variable will decrease 30% to increase 30%. That's the standard process for the sensitivity analysis. The original input, because we don't want the input, later we will conduct the data table function, we don't want this one to link to the original input in the NPV function. For the condition here, we will enter the numbers by ourselves. Unit sale is 60,000. The price is $80. Variable cost per unit is $60 per unit. Fixed cost per year is 50,000. This is the number we want to enter manually. Do not link to the input section because later this is the new numbers. We want to see how the NPV changes related to. We don't want it to link to the original input. Let's first enter the formula to calculate the variation here. The unit sales will equal to the 84 times 1 flow changes. And the C184 we want to add the dollar sign because we want to copy this formula to other variables. Let me show the formula here. Based on the original unit sales, we calculate its changes. And then we link the NPV or the original NPV formula D32. We go to what if analysis data table. The column input cell is D9. Here is our different NPVs for different unit sales. Again, for the base case unit sales, we want to enter here manually because we don't want to mess it up with the NPV formula input. We repeat this process for other variables. Price per unit. Remember to add dollar signs. We can copy to other. Each NPV is equal to D32. And we select the pink area for each variable. Column input is price per unit, D10. And for the variable cost, we repeat the process. The column input cell is D11. For fixed costs, 12. D12. After we complete the full sensitivity analysis table, we can find the updated graph below here. Show the relation between the NPV and the four variables. We can see the sensitivity of NPV to changes in different variables. The steeper of the line, the NPV is more sensitive to this variable. The blue line is for fixed costs. We can see this is the most flat one. That means the NPV is least sensitive to this variable. The green line is the most steep one. That means the NPV is most sensitive to price per unit. Also for the purple one, the variable cost per unit. The NPV is most sensitive to the price and the variable cost.